friends, welcome back to my YouTube channel. So today we are going to discuss about the guided transmission media optical fiber cable. So this is the last one we are discussing. We have already discussed the twisted pair cable and the coaxial cable. The another one is optical fiber cable, OFC. So fiber optical cable is made up of glass or plastic and transmit signals in the form of light. So the signal is transmitted in the form of light. To understand optical fiber, we need to first explore several aspects of the nature of light. And light travels in a straight line as long as it is moving through a single uniform substance. So light travels in a uniform line or straight line without within a medium in the air moving through a single uniform substance. So if a ray of light traveling through a one substance suddenly enters another substance or different density, the ray changes direction. So this is the principle in the fiber optic cable. So the figure in the next slide shows the how a ray of light changes direction when going from a more dense to a less dense substance. So the below figure shows that the first one is less dense and more dense. So I is the critical angle, I is incident angle, and there is a critical angle. So we are discussing this, and if the angle of incidence I, the angle of ray that makes with the line perpendicular to the interface between two substances, is less than the critical angle, the ray refracts and moves closer to the surface. And if the angle of incidence is equal to the critical angle, the light bends along the interface. And if the angle is greater than the critical angle, the light reflects, makes a turn, and travels again in the denser substance. So this is of three figures shows that the first one is I is less than critical angle, so that makes the refraction occurs there, and second one is angle of incidence equal to the critical angle, there is no change, it will bend along the interface. And the third one is I greater than critical angle, the reflection occurs there. So the critical angle is a property of substance and its value differs from one substance to another. So the critical angle value is the value differ from one substance to another, it's the property of a substance. And optical fiber use reflection to guide light through a channel. So reflection is the main part of the optical fiber to guide light through the channel. A glass or plastic core is surrounded by a cladding or less dense or plastic. So in optical fiber, a glass or plastic core is surrounded by a cladding of less dense glass or plastic. So the inner side it's a density higher, and the outer side the cladding is less dense, and the core is high density and cladding of less dense. And the difference in the density of two material between must be such that the beam of light moving through the core reflected off the cladding instead of being refracted. So here happening the reflection, not the refraction. So the figure shows the reflection of light through the optical fiber. The propagation modes are, the current technology supports two modes of propagation. First one is multi-mode and second one is single mode for propagating light along the optical channel, each requiring fiber with different physical characteristics. And also the multi-mode has two types, as step index multi-mode and graded index multi-mode propagation. So these are the propagation modes of optical fiber. So the figure shows the classification of modes of propagation. The first one is multi-mode. In multi-mode is so named because the multiple beams from a light source move through the core in different paths. So multiple beams from the light source move through a core in different paths. How these beams move within the cable depends on the structure of the core. The movement of the light depends upon the structure of the core. So this is shown in the figure in the next slide. In a multimode step index fiber, the density of the core remains constant from center to the edges. So this is the important point. The density of core remains constant from the center to the edges. So this is the characteristics of multimode propagation. The beam of light moves through the constant density in a light line in a straight line until it reaches the interface of the core and the cladding. So beam of light moves through this constant density in a straight line until it reaches the interface of the core and cladding. So this figure shows the multimode step index transmission. So there are so many more than one light moving through the optical fiber and it reaches destination, and at the interface there are the abrupt change due to the lower density, and this alters the angle of the beam's motion. So abrupt change in the lower density and this alters the angle of beam motion. The term step index refers to the suddenness in the change which contributes to distortion of the signals as it passes through the fiber. So in step index refers to suddenness change in the density. So the second type of filter is called a multimode gradient index fiber. So the multimode gradient index fiber means the decrease in the distortion of the signal through the cable. So there is a decrease in the density. So the word index here refers to the index of refraction. As we saw above, the index of refraction is related to density, and the density is related with the refraction index. The gradient index fiber therefore is one with varying density, and the density is highest at the center of the core and decrease gradually to its lowest edge. So density is varying from the core and gradually decreasing at the edge. The figure shows the impact of the variable density on the propagation of light beams. And the second one is, so we have discussed the multimode propagation mode, step index and gradient index, and the second one is single mode. Single mode uses step index fiber as highly focused source of light that limits beam to a small range of angles all close to the horizontal. So step index highly focused source light is used here, and the single mode fiber is itself manufactured with a much smaller diameter than the multimode fiber. So comparing to multimode fiber, single mode uses small diameter and the substantially lower density, so its density is lower, and the decrease of density resulting in critical angle that is close enough to 90 degree to make the propagation of beams almost horizontal. And the beam propagation is different beams is also identical and delays are negligible. All the beams arrive at the destination together and can be combined with the little distortion. So there is only little distortion in single mode, and in this case propagation of different beams are almost identical. The propagation is almost identical and delays are negligible. And in the figure shows the single mode propagation model. So there is only negligible distortion in the signal receiving at the receiver. And the fiber size, and the fibers are defined by the ratio of diameter of their core and the diameter of the cladding. Both are expressed in micrometer. So the table shows the fiber sizes, different fiber sizes, and it's characterized by multimode and gradient index and single mode. So cable composition means the figure in the next slide shows the composition of a typical fiber optic cable. The outer jacket is made up of either PVC or Teflon, and inside the jacket the Kevlar stands to strengthen the cable. And Kevlar is a strong material used in the fabrication of bulletproof vests, and below the Kevlar another plastic coating to cushion the fiber, and the fiber is at the center of the cable and it consists of cladding and core. So this is the composition of the cable, fiber optic cable. The figure shows the outer jacket and plastic buffer and DuPont Kevlar for strength and cladding and glass or plastic core. So this is the structure of fiber optic cable. And fiber optic cable connectors are the three types of connectors are there. One is SC connector and SG connector and MT-RJ connector. So there are three types of connector for fiber optic cable. So the subscriber channel SC connector, subscriber channel connected to user to cable TV, and it uses a push or pull locking system. And the straight tip connector, that means SG connector used for connecting cable to networking devices, and it uses bayonet locking system and is more reliable than SC. And MT-RJ is a connector that is the same size as RJ45. An application of optical fiber system is backbone of SONET, and the cable TV companies uses a combination of optical fiber and coaxial cable. And local area networks such as 100 base FX network, fast Ethernet and 1000 base X also use fiber optic cable. So that's all about the fiber optic cable, and we are discussing now the advantages and disadvantages of optical fiber. The advantages of optical fibers are high bandwidth it provides high bandwidth and less signal attenuation, and fiber optic transmission distance is significantly greater than that of other guided media, and the signal can run for 15 km without requiring regeneration, and immunity to electromagnetic interference is very high, and resistance to corrosive material, and lightweight and great immunity to tapping. And disadvantage is the installation and maintenance is very high, and unidirectional light propagation is happening here, so it cannot be used in the various direction, and the cost, the cable and the interfaces are relatively more expensive. So these are the advantages and disadvantages of optical fiber cable. So that's all about the optical fiber cable. It's a last third of the guided transmission media. So we have discussed, we have completed the three types of transmission media, guided transmission media. First one is twisted pair cable, second one is coaxial cable, and third one is optical fiber cable. So in the next class we are discussing about the unguided transmission media, that means wireless transmission media. So if you like this video, please subscribe my channel. So thank you for watching my video. See you in the next class.